Good morning, students. We are discussing plant growth regulators, right? Plant growth regulators. Till now, we completed auxins, gibberellins, cytokinins. Today, we are going to discuss about abscisic acid. What it is? Abscisic acid, right? Now, listen here. Sir, this abscisic acid, it plays a role in regulating abscission, right? Therefore, it has a role in regulating what's her abscission. Regulating what's her abscission. Is it okay? Sir, this abscisic acid is a plant growth inhibitor. What it is? Plant growth inhibitor. Plant growth inhibitor. Plant growth inhibitor. It is a plant growth inhibitor. Abscisic acid is a plant growth inhibitor, right? Sir, this abscisic acid, it plays a role in seed development, seed development, maturation and dormancy. What? Abscisic acid. Abscisic acid plays a role. Abscisic acid plays a role in what? Seed development, seed development, seed maturation, seed maturation, and what more, sir? Seed dormancy, seed dormancy. Is this statement okay? Therefore, sir, abscisic acid, it is playing a role in seed development, seed maturation and seed dormancy, right? Sir, this abscisic acid, responds to various type of stress created in environment. That's why this abscisic acid is called as a stress hormone. What it is called as a stress hormone. Therefore, abscisic acid ABA respond. ABA, that is abscisic acid, responds to what's various types of what? Various types of stress. Various types of stress created. Various types of stress created in environment. So abscisic acid, is called as what's stress hormone. Which one is called as a stress hormone, sir? Abscisic acid is called as a stress hormone. Why? Because abscisic acid responds to various types of stress created in the environment. Is this statement okay? Right. Now listen this statement. Sir, in water stress conditions, in which conditions, sir? Water stress conditions, this abscisic acid drive out the K plus ions out of the guard cell. It is driving out the K plus ions from the guard cell. If K plus ions comes out of the guard cells, the stoma or stomata gets closed. This is in which conditions? Water stress conditions. Sir, availability of water is less to the plant. Water stress conditions. Then the plant has to lose less amount of water. How it is going to lose less amount of water? If it closes its stomata, it loses less amount of water. Yes or no? It means the stomata should be closed. Who is helping in this closing of stomata, sir? Abscisic acid. How? By sending the K plus ions out of the guard cell. Is this statement okay? Therefore, in which conditions, sir? In water stress conditions. In water stress conditions. In water stress conditions. In water stress conditions, right? What abscisic acid is doing, sir? This ABA, that is abscisic acid, what it does? Drive out what? K plus ions from guard cells. Is this statement okay? It means the K plus ions are going to come out from which cells, sir? Guard cells. Is it okay? So what happens? Stoma or stomata gets closed. Stomata closed. Therefore, to this water stress conditions created in the environment, which phytohormone is responding? Abscisic acid is responding and closing what, sir? Stomata. Closing stomata. Therefore, abscisic acid is responding to water stress conditions. So, abscisic acid is a water stress hormone. So, abscisic acid is a what, sir? It is a water stress hormone. It is a water stress hormone. It is a water stress hormone. Is this statement okay? Now you tell me, sir, if stomata gets closed, okay, who is helping in this closure of stomata? Abscisic acid. If stomata gets closed, the rate of transpiration decreases. Yes or no? Transpiration decreases. Therefore, abscisic acid, it acts as a natural anti-transpirant. Abscisic acid acts as what? ABA. Abscisic acid acts as a natural, what's a anti-transpirant. Acts as a natural anti-transpirant. Why we are calling abscisic acid as a anti-transpirant, sir? Because it is closing the stomata. If stomata gets closed, rate of transpiration decreases. Therefore, abscisic acid, right, it is decreasing the rate of transpiration by closing the stomata. So, abscisic acid, it acts as a natural anti-transpirant. Is this statement okay? Right? Now, listen this statement. Sir, cytokinins helps in opening of stomata. Abscisic acid helps in closing of stomata. Yes or no? This statement we already read. What it is, sir? Cytokinins. Cytokinins helps in opening of stomata. Helps in what, sir? Opening. Helps in opening of what, sir? Stomata. Helps in opening of stomata. Whereas abscisic acid, ABA, abscisic acid, what it is doing, sir? Closing stomata. It is closing the stomata. Is this statement okay? Now listen this statement. Sir, this abscisic acid is responsible for seed dormancy. Which phytohormone is responsible for seed dormancy, sir? Abscisic acid. Abscisic acid, ABA. Right? Responsible. Abscisic acid is responsible for what, sir? Seed dormancy. Responsible for seed dormancy. Now listen this statement. Sir, if this seed undergoes dormancy, is there any use, sir? Yes, it's useful to plant. How, sir? The plant is facing unfavorable conditions in the form of seed by undergoing dormancy. It means surviving, not surviving. Right? The seed is surviving by undergoing dormancy during unfavorable conditions. Yes or no? Sir, conditions are unfavorable. In unfavorable conditions, the seed cannot germinate. If it tries to germinate, the seed will die. In such cases, the seed is undergoing dormancy. It means the seed is surviving during unfavorable conditions by undergoing dormancy. Yes or no? Therefore, it will be useful only, no? Right? Therefore, sir, during unfavorable conditions, the seed undergoes dormancy. The seed undergoes what, sir? Dormancy. Is this statement okay? Right? Therefore, seed, what it is doing, sir? Seed facing which conditions? Unfavorable conditions. Right? Seed is facing this unfavorable what? Conditions. Unfavorable conditions by what? Undergoing dormancy. Is this statement okay? Therefore, seed is facing these unfavorable conditions by undergoing what, sir? Dormancy. This dormancy is with the help of what? Abscisic acid. Once conditions becomes favorable, then seed starts germinating. It means seed, right, it is facing these unfavorable conditions by undergoing what, sir? Dormancy. By undergoing what, sir? Dormancy. Right? Now listen, we are discussing abscisic acid, right? or it is a abscisic acid. Abscisic acid. Sir, by undergoing seed dormancy, right, the seed is protected from desiccation. Desiccation means drying, yes or no, right? Therefore, by undergoing what's there, seed dormancy, by undergoing seed dormancy, right, seed protected from what's sir, desiccation. What is the meaning of desiccation, sir? Desiccation means drying. What is the meaning of desiccation, sir? Drying. Is it okay? Sir, in aquatic plants, in which plants, sir? Aquatic plants, that is hydrophytes, right? In aquatic plants, during unfavorable conditions, during which conditions, sir? During unfavorable conditions, this abscisic acid ABA, this abscisic acid, right, abscisic acid forms permeating buds. Forms which buds, sir? Permeating buds. It forms permeating buds. Forms which buds, sir? Permeating buds. Is this statement okay? Sir, what is the use of this permeating buds, sir? Sir, plant is facing unfavorable conditions not in the form of a plant, in the form of this permeating buds. For example, take a water body. In that water body, a aquatic plant is present. If conditions becomes unfavorable, then abscisic acid, it forms this permeating buds. After formation of permeating buds, the plant will die. Now the permeating buds will fall to the bottom of that water body. It means now plant is not in the form of a plant, it is in the form of permeating buds. Yes or no? Right. Once favorable conditions arrives, that permeating buds starts germinating. It means the plant is facing unfavorable conditions in the form of what, sir? Permeating buds. Plant is facing unfavorable conditions in the form of permeating buds. Is it okay? Right. Now listen this statement. In most of the cases, abscisic acid is antagonistic to gibberellic acid. In most of the cases, right? In most of the cases, right, abscisic acid ABA, abscisic acid is antagonistic. Abscisic acid is antagonistic to what's, sir? Gibberellic acid. Gibberellic acid. Is this statement okay? Sir, this gibberellic acid, it promotes seed germination in most of the plants. Yes or no? Whereas this abscisic acid, it is preventing the seed germination. Promotes seed germination, prevents seed germination. Is this statement okay? Sir, abscisic acid is preventing the seed germination. It helps in seed dormancy. It promotes seed dormancy, whereas it breaks seed dormancy. Promotes seed dormancy, breaks seed dormancy. Is this statement okay? What is this one, sir? Abscisic acid. Sir, abscisic acid, right, it promotes abscisic acid, what, sir? It is promoting. It promotes what? Seed dormancy. Promotes seed dormancy. Whereas gibberellic acid, what it is doing? Breaks what, sir? Breaks seed dormancy. Breaks seed dormancy in many plants. In many plants, it is breaking the seed dormancy. Okay. Sir, this abscisic acid, it prevents seed germination. It is preventing the seed germination. It is preventing the seed germination. Whereas this gibberellic acid, what it is, sir? Gibberellic acid promotes what, sir? It promotes seed germination. Promotes seed germination. Is it okay? Right? With this, we completed what, sir? Abscisic acid. Abscisic acid. Right? Now go for the next one, ethylene. Okay, right? Now listen here. Sir, this ethylene, it is a simple gaseous plant growth regulator. Plant growth regulator. Sir, it is having growth promoting activities, also growth inhibiting activities, but most of its activities are growth inhibiting activities. We discussed this statement in introduction class. Yes or no? Right. Therefore, sir, it is a simple gaseous, right, plant growth what? Regulator. Plant growth regulator. It is a simple gaseous plant growth regulator. Sir, synthesized in large quantities. What, sir? Synthesized in what? Large quantities. Synthesized in large quantities by organs undergoing senescence or tissues undergoing what, sir? Senescence. And what, sir? Ripening fruits. Is this statement okay? See this statement? Sir, ethylene, it is synthesized in large quantities. By whom, sir? Organs or tissues that are undergoing senescence. Okay, right, and the fruits which are undergoing ripening. Which are undergoing what, sir? Ripening. Which are undergoing ripening. Is it okay? Therefore, fruits that are undergoing ripening, organs or tissues that are undergoing senescence, in such cases, right, this ethylene is synthesized in large quantities. Synthesized in large quantities. Is it okay? Now go for physiological effects of ethylene. Physiological effects of ethylene, right? Go for physiological effects of ethylene. What's the physiological effects of ethylene, right? Number one, go for the first one. Listen. Sir, this ethylene, it promotes root growth. Ethylene promotes root growth. Promotes what, sir? Root growth and formation of root hairs. Formation of root hairs. Sir, if root growth and root hairs are formed, automatically the area under absorption increases. Area under absorption increases, right? Therefore, promotes who? Ethylene. Promotes what? Promotes root growth and what more? Root hair formation. Promotes root growth and root hair formation. So, surface area. So, surface area of absorption. What's a surface area of absorption increases. Is it okay? Right? Number two, second one. In deep water rice plants, in deep water rice plants, sir, rice, oryza sativa, right? In deep water rice plants, this ethylene elongates the internodes of the stem. If internodes of the stem elongates, the upper part of the shoot system comes to the water surface. What are elongated? Internodes of the stem gets elongated. Sir, if internodes of the stem gets elongated, what happens, sir? Automatically the upper part of the shoot system becomes, right, comes to the water surface. Comes to the water surface. Is it okay? Right. Therefore, in deep water, what? Rice plants. In deep water rice plants, ethylene elongates. Sir, what it elongates, sir? Elongates internodes of stem. Internodes of stem or petiole. What is the meaning of petiole? Stalk of leaf. Therefore, petiole of leaf. Sir, if internodes of the stem elongates, what happens? Upper part of shoot comes to water surface. What comes to water surface? Upper part of the shoot system comes to the water surface. Sir, if petiole elongates, what happens? If petiole elongates, what happens, sir? Leaf comes to the water surface. Leaf, comes to what, sir? Water surface. Leaf comes to the water surface. Is this statement okay? Therefore, ethylene, it elongates the internodes of the stem or petiole of the leaf, by which upper part of the shoot or leaf comes to the water surface. Is it okay? Right? Next, number 3. Sir, this ethylene, it promotes what, sir? Ethylene, it promotes senescence and abscission of plant organs, especially leaves and fruits. Especially what, sir? Leaves and fruits, right? Therefore, promotes what? Promotes what and what, sir? Senescence and abscission. Senescence and abscission of plant organs. Especially what and what, sir? Especially leaves and fruits. Especially leaves and what, sir? Fruits. Is this statement okay? Right? Therefore, sir, we are discussing physiological effects of what, sir? Ethylene. Sir, this ethylene, it promotes what, sir? It promotes senescence and abscission. Promotes what, sir? Senescence and abscission of what and what? Plant organs, especially leaves and fruits. Especially what, sir? Leaves and fruits, right? Now listen here. Sir, we are discussing physiological effects of what? Ethylene, right? Sir, this ethylene promotes what, sir? Senescence and abscission. Promotes senescence and abscission of what, sir? Plant organs. Promotes senescence and abscission of plant organs, especially leaves and flowers. Sorry, this is flowers, right? It promotes senescence and abscission of leaves and what, sir? Flowers. Leaves and flowers. It's not fruit, it is flowers. Okay? Therefore, it promotes senescence and abscission of plant organs, especially leaves and flowers. Leaves and flowers. Right. Now go for the next physiological effect of ethylene. Listen here. Sir, this ethylene, what it is? Ethylene. Sir, this ethylene, what it does means it promotes flowering in pineapple, right, and synchronous fruit setting in pineapple. Therefore, promotes what? Promotes flowering. Promotes flowering and synchronous. What, sir? Synchronous. Synchronous fruit setting. Synchronous fruit setting. In which plant, sir? Pineapple plant. See this statement carefully once. Sir, this ethylene, it is promoting what, sir? It is promoting flowering. In which plant, sir? Pineapple plant. It also promotes what, sir? Synchronous fruit setting in pineapple plant. Sir, synchronous means simultaneously. Simultaneously. What is the meaning of synchronous? Simultaneously, at the same time. Okay, right. Fruit setting in which plant, sir? Pineapple plant. What is the scientific name of pineapple plant? Ananas sativus. Ananas sativus. Sir, in pineapple plant, which fruit is present, sir? Sorosis. Sorosis. Sir, this sorosis is a type of which fruit, sir? Sorosis is a type of multiple fruit. We read it in first year. Yes or no? Right. Sir, what is another name for multiple fruit? Multiple fruit is also called as compound fruit or composite fruit. Yes or no? Compound fruit or composite fruit. Therefore, ethylene promotes flowering and synchronous fruit setting in pineapple. Sir, pineapple scientific name is Ananas sativus. Ananas sativus. Sir, in pineapple, what it is? In pineapple, right, which fruit is present? Sorosis. Sorosis is a type of multiple fruit, a type of compound fruit or composite fruit. Is it okay? Now, listen this statement. Sir, in pineapple, in what, sir? In pineapple, right, flowering is initiated by number 1, auxins. Number 2, what, sir? Ethylene. Yes or no? Right. Therefore, what and what, sir? Auxins and ethylene promotes flowering. Promotes what? Flowering. Promotes flowering in which plant, sir? Pineapple plant. Is it okay? Right. Now go for next physiological effect of what? Ethylene. Okay. What it is? Sir, it also promotes flowering in mango. Also promotes what? Flowering. Also promotes flowering in which plant, sir? Mango plant. Sir, what is the scientific name of mango plant, sir? Mangifera indica. Yes or no? Right, it belongs to which family? Anacardiaceae family. Belongs to Anacardiaceae family. Belongs to Anacardiaceae family. Right. Which fruit is present in the case of mango, sir? Drupe fruit is present. Drupe is present in the case of mango. Right. Therefore, sir, this ethylene, it promotes flowering in pineapple. It is also promoting flowering in the case of which plant, sir? Mango plant. Okay. Right. Next, number 6. Sir, this ethylene helps in fruit ripening. That's why ethylene is called as a fruit ripening hormone. Who is called as a fruit ripening hormone? Ethylene. Right. Sir, ethylene helps in what, sir? Helps in fruit ripening. Helps in fruit ripening. So, ethylene called as what, sir? Fruit ripening hormone. Ethylene is called as a fruit ripening hormone. Who is called as a fruit ripening hormone? Ethylene is called as a fruit ripening hormone. Now listen this statement. Sir, during fruit ripening, rate of respiration increases. Therefore, ethylene enhances rate of respiration during fruit ripening. This enhancement in rate of respiration is called as respiratory climatic. What it is called as a respiratory climatic. Is it okay? Right? Sir, ethylene, nothing but ethylene, right? It enhances rate of respiration. It enhances what, sir? Rate of respiration during fruit ripening. During fruit ripening, right? This increase in respiration. This increase in respiration when during fruit ripening is called as a, what it is called as? Respiratory climatic. What it is called as a respiratory climatic. Respiratory climatic. Is it okay? Right? Next, number 7. Sir, ethylene, it shows triple response growth on stem. Ethylene shows what, sir? Triple means 3. Yes or no? Triple response growth. shows triple response growth on what, sir? Stem. What is that triple response growth on stem, sir? Triple response growth on stem, right? Number one, first one, horizontal growth of stem. Horizontal growth. Horizontal growth of what, sir? Stem. Horizontal growth of stem. Sir, horizontal growth means, can we call it as a geotropism? Yes. Geotropism. Geotropism. Horizontal growth. Right. Number two, we are discussing what, sir? Triple response growth on stem. Yes or no? Who is responsible for triple response growth on stem? Ethylene, right? Number one, what is the first one? Horizontal growth of a stem. Horizontal growth of stem, right? Number two, apical hook formation. Apical hook formation. Apical hook formation in what, sir? Dicot seedling. In what, sir? Dicot seedling. Okay, right? Sir, this apical hook is also called as a epicotyle hook. It is also called as what, sir? Epicotyle hook. Therefore, apical hook formation in dicot seedling. Apical hook formation in what, sir? Dicot seedling. Next, number three, what it is? Swollen axis. Swollen axis. Swollen axis. Is it okay? Therefore, ethylene shows a triple response growth on stem. Number one, horizontal growth of stem, that is a diageotropism. Number two, apical hook formation in dicot seedling, that is epicotyle hook formation in dicot seedling, right? And third one is a swollen axis. Swollen axis. Sir, ethylene, one of the most widely used phytohormone in agriculture. Ethylene, one of the most widely used phytohormone, one of the most widely used phytohormone in agriculture. One of the most widely used phytohormone in agriculture. What it is, sir? Ethylene, right?